dividing polynomials. So there's two main ways that you probably remember dividing polynomials when you guys were in algebra, or that. And then one is considered the long division. Now, I know this is kind of redundant, but I always start with just a simple problem. Like if let's say that I have 326, okay? And I'm dividing that, all right? Well, we know that when we did that, we first started looking to see if 5 went into 3, and it doesn't. So then you went into 5 goes into 32, and you go, yeah, it does, 6 times. So I'm going to put a 6 here. And then I multiplied the 6 times 5 and got 30, right? And then what did you bring down? 2, because you subtracted them, right? So you subtracted 32 from 2, or 30 from 32 and got 2, and then 6. And then we went 5 goes into 26 5 times, and then we went 25. We bring down 6 minus 5 would be 1. And then we got down to where we started working on our decimals, right? Before you did the decimals, sometimes you actually put remainder 1, but then you sometimes put it as a fraction, right? So this would be the same as 65 and 1 over what? What did we do? You put your remainder divided by what you're dividing it by. So it would be the same as 1/5. So when I did the division, when you were in what? Gosh, that would have probably been 3rd grade? I mean, this is like going way back, isn't it? Polynomials really much different than just that same process that we just did. When I take the polynomial 6x to the third plus 17x squared plus 27x plus 20, and I'm dividing it by 3x plus 4. Now, what I'm going to end up doing is pulling inside my polynomial. Now, one thing you do need to remember is when you divide, each one of my terms need to be represented, okay? And that would be the new change. But in this case, I go x to the third, x squared, x, and just the constant. So I'm good. So I'm just going to write that inside my division box. So 6x to the third plus 17x squared plus 27x plus 20. And then on the outside, I'm going to go ahead and put on what I'm dividing it by, which is going to be 3x plus 4. Now what we do on this one is I start off with my first term, and I say I have 6x to the third. And so what you ask yourself is, what do I need to multiply 3x by to get 6x to the third? Well, 3 times what is 6? 2. So we know it's going to be a 2. I already have an x, but I need an x to the third, so I'm going to have to go 2x squared, because x squared times x is going to be x to the third. But then I multiply, just like I did before when I did my old problem. I multiplied the 6 times 5 and got 30. I'm going to multiply the 2x squared times the 3x plus 4. So this always should be the same number. So 6x to the third, and then I'm going to multiply 2 times 4, and I'm going to get 8x squared. And this is going to be plus. So then, when I divide, the next step, remember we subtracted 32 from 30, correct? You need to remember I'm subtracting this whole thing. And so when you subtract it, what I try to do is when I draw the line here, I change these to the signs. And then I just know that I'm subtracting it by adding the opposite. So I'm going to make this a minus, but I'm also going to put a little minus here to remind me that I'm going to take 17x squared minus 8x squared, because if I add them, that wouldn't be what we did earlier. Okay, does that make sense? And of course, I know my first term is going to cancel. That's why I multiplied it times 2x squared. So 17x squared minus 8x squared would give me 9x squared. Good. And then I'm going to drop down that 27, just like I did the 6 earlier. So I'm going to go plus 27x. And I wrote just 2x. Goodness. All right. So then I'm going to ask myself again, 3x times what is going to give me 9x squared? 3x. Yep. So I'm going to put a 3x here, and I'm going to multiply it both of my terms. So I'm going to get 9x squared here. 3x times 4 would be then 12x. And then I had the plus, but when I draw the line, I'm going to change both of my signs. And so then I'm going to end up with the 9x squared is canceling out, and I have 27x minus 12x. So that would be then 15x. Then I'm going to drop down what? The 20. You guys are so good. So then I'm going to end up with 3 times what is 15? So you're going to go, well, it's 5. And then I already have the x, so I'm going to just go plus 5, and I'm going to 15x plus 20. It's the same thing, so that means I had no remainder, so I'm just going to go ahead equals 0. So what this means then is 2x squared plus 3x plus 5. Remember, times then 3x plus 4 would give me then the original problem I have here. So this quotient is going to be then the 2x squared plus 3x plus 5, and my remainder would be then in 0 in this case. But remember, it would be the same as my factored form. Like I could write this as a factored form from what I multiplied here, just like I could up here when I said that this times this should give me the 326. Let's go ahead and do another problem with it this time. But what we just did is what we call long division. Now, synthetic division just simplifies that a little bit. Okay, the nice thing about the synthetic division is that it takes your long division and it condenses it down just to the coefficients. And it only works, okay, keep in mind, it has to be when you're dividing it by x minus c. Keep that in mind. If I'm dividing it by a squared, like in other words, like a quadratic, so it's x squared minus 5. I can't use synthetic division, but I can anytime it's just going to be that single x minus c, x minus a constant. So in this case, they start off with the example. They're going to divide the x to the third plus 4x squared minus 5x plus 5 by x minus 3. And what you'll do is you find your constant. So in other words, it's going to look like the opposite here, and that's going to be what's going to go inside your box. And then you're going to represent every one of your terms, or the coefficients. So in other words, then the x to the third is going to be the 1. I'm going to take the 4x squared. I'm going to just put a 4. I'm going to put 5 minus 5x and put a minus 5, and then I have plus 5. Now keep in mind, I have to represent every one of my digits, and it does go x to the third, x squared, x, and then the constant.
I have a question. So when you went from x minus 3 and then put 3, so it's the opposite?
It'll look like the opposite because it's the factored that you really want. So just like we did with the zeros, and if I had this as a factor of x plus 2, then remember we said the 0 was negative 2. Okay. And so the same thing goes, like if I'm doing my long division, I'm going to use negative 2, which is going to look like the opposite. Okay. How's that? Maybe a little more clear. Okay, so what you do is you're going to draw your line, and you take your first term and you just bring it down. Okay, so I'm going to start off by just dropping the 1 down. And then I'm going to multiply then 3 times 1. 3 times 1 is going to be 3. But then I'm going to subtract this down from now on. So 4 minus 3 is going to also be 1. And then I'm... Oh, we add it. Sorry, we are going to add it. 3 plus 4. 4 plus 3 is going to be 7. 3 times 7 is going to be 21. And then I'm going to add this together. So negative 5 plus 21 is going to give me then the 16. And then 3 times 16 is going to be 48. And 48 plus 5 is going to be then the 53. So what then this gives me is my reduced polynomial. If I start off this inside with this one was an x to the third. So that means my reduced polynomial will start off with then 1x squared. I'm going to reduce it by 1. Then I'll go plus 7x plus 16. And then the 53 is going to be my remainder. So if I want to write it as I'd be 50 divided by x minus 3.
Okay.
Can you raise it up?
Yes. It's kind of on that thing, isn't it? Sorry. I'll let you write it. Now, I wouldn't put the 1 here. I just wanted to represent that that's there. So it really would be just the x squared plus 7x plus 16.
Did the end you always go 1 less for the exponent than it was originally?
Exactly. Because what you're doing when you divide it by x, we're really dividing this by x minus 3. And so
take away
you're going down 1 level. So, all right. So then what we find is that when we do divide using synthetic division, again, so let's practice again. So inside my box, if I have an x minus 2, what will go in here? 2. Right, it's going to look like the opposite. And I have x to the third, x squared, x, and then the constant. So I have every one of my digits represented so that I'm going to write the leading coefficients. So 5, negative 6, 3, and 11. Okay, I'm going to start by just dropping the 5 down. So 5 is going to begin.
And then 2 times 5 is
10. So I'm going to add them. Then I have x plus 10 is going to be 4. 4 times 2 is 8.
And you added
11.
22 plus 11 is 33.
Yep. So my answer will be then 5x to what power? Squared. Good. Plus 4x plus 11. Then plus my remainder, which is going to be 33 over, so 33 over x minus 2.
Okay, that's not bad.
Not bad. I like synthetic. Now, some kids like the long division more than they like and I don't quite, I've never understood that quite right, but the remainder theorem gives us a really cool thing. So here's what's so awesome about this. When I do, like if I'm looking for f of negative 2, if I'm looking for the value of f of negative 2, what we find is that when I substitute this in and I divided it with my synthetic division, whatever my remainder was, for instance, like if I wanted what f of 2 was from my equation right up here, I'm just going to show you. We've always done this where we went 5 times 2 to the third minus 6 times 2 squared, right? Plus 3 times 2, and I ran out of room. Hold on. Let's start over again. I thought I had longer my page because my page was so. Let's go 5 times 2 to the third minus 6 times 2 squared. Grab your calculator and minus 6 times 2 squared plus 3 times 2 plus 11. Okay, we know we've done that before. And so if I actually work that out, I'm going to get, so let me go, 5 times 2 to the third minus 6 times 2 squared. Plus 3 times 2 plus 11. I got 30. So double check your work.
Don't you have to put the 2 in parentheses though?
On this one I'm doing it. It shouldn't matter. I'm not sure what you did, but I'm pretty sure it's 13.
It's to the third.
So notice that is also.
It's fine.
You guys want to just trust me? It's 33.
Yeah, it's fine.
Okay. So notice that's the same thing I got when I had my division. So our remainder theorem will actually say that if I were to work my problem with synthetic division, whatever I get as my remainder is also going to be f of that same number. It also works out if I wanted to know what let's say that I have a factor of this. If I knew that the number went in evenly and this would happen to be 0, that means that it's going to be then a solution or a 0 of my equation. It's also going to be a factor of the polynomial. So the remainder theorem tells us that if we want to find some of these values that are make it a little easier, using synthetic division could be simply plugging it in and doing it that way. We're going to get the same answer. So if I'm looking for f of negative 2, don't change it. Keep it as negative 2. But then I'm going to go ahead and do synthetic division. So I'm going to have a 4, I'm going to have a 5, I'm going to have a negative 6, I'm going to have a negative 4. So again, check. You want 3, 2, 1, and then the constant. Okay?
If you don't, what happens if
You add a 0 in there. I was going to do an example of that one. Probably tomorrow or on Monday. So I'm going to start on this one. I'm going to drop down my 4. I'm going to put a 4 here. 4 times negative 2 is negative 8. 5 plus negative 8 would be the negative 3. Negative 3 times a negative 2 is going to be a positive 6. So then I'm going to have 0. Then I'm going to have 0, and then I'm going to have a negative 4. If I were to graph this, then I know that also, when x is equal to negative 2, y is going to equal a negative 4. So now f of negative 2 is going to equal negative 4. Okay? If it happens to be 0, because of the factor theorem says that if this number here was 0, then that indicates that that is a factor of the original polynomial. So, like for instance, solve the equation, and it says given that negative 1/3 is going to be a root. So they already told us that if I were to find the root of this, that means that if I were to graph it, that it's going to cross and be 0 at negative 1/3. But it also should make sense that at negative 1/3, if I do synthetic division, will also come up as 0 at the bottom. So let's just check it. So I'm going to go 3. My next one is going to be 7. I'm going to go negative 22, and then I'm going to go negative 8. I'm going to drop down my 3, so I'm going to have a 3 here. 3 times negative 1/3.
negative 1?
Perfect. Negative 1. 7 plus a negative 1 is 6. 6 times negative 1/3?
Negative 2.
Perfect. Then I'm going to go negative 2. 22 minus 2 would be a negative 24. Negative 22, 4 times negative 1/3 is a positive, but you'll have positive 8, and so therefore it is going to end up being 0. And that's a way that you're going to show that it's going to be a root. Therefore, this would factor to 3x squared plus 7x, or not 7x, sorry, 6x. 3x squared plus 6x minus 24. And then it'd also be that I would have an x plus 1/3 as one of my factors. Okay? Which also means a negative 1/3 is going to be one of my roots. And root means that it crosses the x-axis at that point. So let's go ahead, since I was thinking this was going to be it, let's go ahead and just say that we were going to go ahead and have, let's say f of x. I'm going to make sure that we have one that's missing. So we know that if I have x to the 4th power minus 16, we've already done that one before when we found the roots, and it was, remember we found that we simplified it. That's x to squared. We know that this factors to x squared minus 4 times x squared plus 4, right? Mm-hmm. And that also means that x is going to equal then equals then plus or minus 2, and then this one with the negative 2 would be an imaginary. Okay, so we did that one kind of earlier. Let's just check it with synthetic division. So let's just say that I want to check, is 2 going to be a root? And so because it's x to the 4th, I'm going to start off with 1x to the 4th, but I have 0x to the 3rds. So I would have to go 0. I have 0x squared, so that's going to also be 0. I have 0 x's, but then I have that minus 16. Does that make sense on how I'm representing each one? So this went x to the 4th, x to the 3rd, x squared, x, and then the constant. But then I'm going to just go ahead and work this problem. I'm going to drop the 1 down. I'm going to put a 2. So 2 times 2 is going to be then 4. I'm going to go 0 plus 4 is going to be 4. 4 plus 2 is going to be 8. I'm going to drop down the 8. And then I'm going to go, oh, I should have 1 x to the 4th. Did I go 1?
I think that's right.
So drop down that 4.
Well,
Drop the 4, 8, 8. I'm going to go 16, but I'm going to get 32 here. So x to the 4th, x to the 3rd, x squared, x.
Because you put 2 there.
Oh, I did! Thank you for catching it. Yes, it should be 1. Duh. And that would help. So 1 here, then this one's going to be 2. There we go. Thank you for catching my error. 2 times 2 is going to be then 4. Then I'm going to bring a 4 down. Then I'm going to put down an 8. 8, and then I'm going to have an 8, and then I'm going to have the 16, and that's going to be 0. So then, therefore, it does show that it's going to be a factor. Okay? And that's how you will also represent your holes in your graph, was just 0 times that. Kind of makes sense?
Yeah.